All right, so we're going to talk about a new value in this video, and to kind of illustrate what's going on with it a little bit, we're going to look at three sets of data here. Below the scores for three groups of students on a 10-point quiz. Find the mean, median, and range for the scores of each group. And I'm going to save a little bit of time with these. What turns out to be the case is that when you find the mean of all three of these, the mean is 5. If you actually type those in to your calculator and did one var stats, the mean is 5. The median happens to also be 5 for each of these data sets. The range is 9 minus 1 for all three of these data sets. But we can look at them and see, well, they're not exactly the same numbers. This one has 4 nines, this one only has 1. Here's what the pictures look like. So these are the dot plots. They don't look anything alike at all. We've got this one here that has half the points in the middle, or most of the points, or a big chunk of the points right in the middle of the graph, near the mean. And we've got this one here that has no points in the middle. In fact, most of the points are spread toward the edge. And then this one's kind of in between. So we need some other way to measure what's going on here, because our mean, our median, our range is exactly the same for three sets of data that are not exactly the same. So some ways that we measure spread. We talked about the range before, max minus min. That's one way to measure how spread out your data is. IQR is another way to measure spread, taking Q3 minus Q1. We're going to add a new measurement for spread that will help us with that last scenario called standard deviation. Now, standard deviation is the one we use by far more right now, but variance is one that's related, and later in the year we need to know variance. So we're going to talk about both right now. This is how you calculate the standard deviation. It's a messy formula. It looks gross. The good news is you're never going to have to do it by hand, but I do want you to know what's going on. These xi mean we're going to take each number in the list. So this is maybe the better way to look at it with the formula written out. This is saying you would take the first number in your list minus the mean of all the numbers. Then whatever answer we get, we're going to square it, and then we're going to do that over and over again. So then you take the second number minus the mean, square the answer. Third number minus the mean, square the answer. And the idea is, what we're really measuring is how far off is each point from the mean. The reason we do the squaring is some points are going to be above the mean, some points are going to be below the mean. And if we added together a bunch of positive values with a bunch of negative values, they would all cancel out. So squaring kind of gives you a way to make them all positive, so you can kind of just see how far off they are instead of how far above or below. And then the one catch, and that's a little bit complicated to explain, is this is kind of an average. It's almost an average. But instead of dividing by the number of numbers, we divide by the number of numbers minus 1. The real reasoning is a way beyond the course of even most college classes, called something called degrees of freedom, the full scope of it. For now, you just need to know that it's not quite an average. It's roughly an average is what I'm going to tell you later. Variance is very similar, except there's no square root. So the main takeaway you need to know about standard deviation and variance, standard deviation we're going to use more. We'll have the calculator calculate it. I'll show you how. But it's important to know that standard deviation is the square root of the variance, and that variance is standard deviation squared. This I would definitely get in my notes. There are times that's come up in a couple of different ways in multiple choice questions. Sometimes they might give you the variance, but you need to use the standard deviation. You need to know you can square root that variance to get your standard deviation. You do not need to write one out like this, but I just want to show you how it works. If I take the numbers 1, 1, 3, 8, 9 and find the average is 4.4. So if I was going to use this formula, I would start with my square root. Then I would have 1 over 5 minus 1, because there's 5 numbers here. So I'd have 1 over 4 at the beginning. And then in a big set of parentheses or brackets, I'm going to take each number minus the mean and square the answer. Then I'll take the next number, which happens to be a 1 again, subtract the mean, square the answer. Then I take the next number, square the mean, or subtract the mean, not square the mean, subtract the mean, square the answer. Next number, minus the mean, square the answer. Next number, minus the mean, square the answer. And then you could theoretically type that all into your calculator. But that's with only 5 numbers. If you've got a list of 20 numbers, gross. So what we're going to do is put those numbers in a list, and that same one var stats we used before is going to spit out our standard deviation. Here's where we need to be really, really, really careful. You are always going to use SX when you do one var stats. There's a reason you learned sigma before, and it wasn't wrong then. They were just dealing with a different circumstance, your Algebra 2 books. What you need to know is you will always use SX on the calculator if it's there. There is a case later in the year where SX will be blank. That's the only time we use sigma, and there's reasons why. But for us, our standard deviation here for that set of data would be 3.85. Just be warned, make sure you're looking closely. These are never going to be super far off, but they will be different. Make sure you are looking closely. And also make sure you don't just chop off values. 3.84 is wrong. You could go 3.847, but if you're going to go to 2 decimal places, that 7 would round that up to a 5. Please make sure you're rounding correctly. So let's return to our data sets from before. When we look at these three, the whole idea here based on the formula is we're measuring how far each number is away from the mean. So when we look at these, the mean of all of these was in the middle. The largest standard deviation should be the one that has its points furthest from the mean. So when we see a graph like this with points way out near the edges, that should be our largest standard deviation. The smallest standard deviation is going to be the one that has most of its points close to the middle. So since this has most of its points close to the mean, that should be the smallest standard deviation. And then this, there isn't really no way to like just guess the decimal, but it should be between those two. And what I just did, where they give you 3 graphs like this, and then ask you to rank them in order of standard deviation, that's a super common multiple choice question on the AP exam. It's even more common on my exams or my quizzes for this unit. So be ready to understand that thinking and ask questions if you don't get it. Now, the one other thing that you need to know how to do is interpret or explain what this value means. And this is going to be the first of a series of statements throughout the year that you kind of got to study and almost kind of memorize, at least parts of them, because there are some key things they'll look for if they ask you to do this on the AP exam. So, if you are asked to interpret, what do we mean by interpret the standard deviation here? What does that mean? If you're asked to interpret standard deviation, you should say that standard deviation is roughly the average distance from each point to the mean. It's really important that you have roughly the average because it is not a true average. And this roughly is not like an approximate. We're not saying, oh, the standard deviation's approximately 3.85. The roughly is tied to the word average because it's not a true average. So we're saying that standard deviation is not an average distance, it's roughly the average distance from each point to the mean. And then if they ask you to do it in context, like these are quiz scores, we would say 3.89 is roughly the average distance from each quiz score to the mean quiz score. So you're just inserting like what is a data point here and what is the mean that you're finding for that set of data points. Excuse me. But that's standard deviation.